you everyone for attending the session on the Next Wave of Renewables at the Users Forum of URI. I would like to introduce you the moderator for this session, Brian Ross, who is the Vice President of the Great Plains Institute. Brian, in his position, leads the energy renewable market transformation effort of the Institute and nationally. I direct technical assistance also for the National Smart Certification Program for local governments, and is helping lead national research efforts on integrating renewable energy development with natural systems for water quality benefit, and is developing work on electrical integration of renewable energy systems. And with this, I'll let you I'll let the podium to Brian, who will introduce our panelists and start the session. Thank you.
Okay, thank you, everyone. I'm going to spare you a presentation by me, but I just kind of wanted to set the stage a little bit for this discussion. I do a lot of work in renewable energy on wind and solar energy, which in the years past meant a lot of trying to bring things to market and do market transformation work. And we've gotten to the point now where wind and solar are the cheapest forms of electric generation in the world. And so in some ways we say, okay, job done, right? Except there's all kinds of other barriers that are in the way to actual deployment and to real market transformation. And I think that we're not quite in the same level with a lot of our agricultural-based renewable energy products and services. And I think we're going to hear a little about that today and talk a little bit about some of those market transformation efforts and market opportunities as we move forward. So let's go get started right away here, and I will introduce the speakers. Our process here is that I'll give an introduction, and we'll hear from each of our panelists. We have 4 panelists today, and they will give just a relatively short presentation of 5 minutes. So and then we'll have some discussion about each other's presentation and about the products and services that they're going to be explaining, and also opportunity, of course, for the audience, both remote and in person, to ask questions as well. So let's go ahead and get started with our first panelist, and that is Michele Rubino, and Michele is remote. He's up here on the screen. Michele is a business professional with extensive track record in clean technology and biotechnology. He has over 2 decades of experience in the biofuel sector across different regions and spanning many different roles. He was involved in the early days of the biodiesel industry in Europe and with the ethanol industry in the United States. Over the past 10 years, he has focused on advanced or second generation biofuels. So, Michele, go ahead and take over the presentation, and when you need to advance, tell us and we will advance it.
Great. Thank you, Brian, for the introduction, and thank you, Auri, for inviting me to participate in this very interesting event. Again, my name is Michele Rubino, and as Brian said, I've been involved in the renewable fuels industry for over 2 decades, spanning different agricultural inputs from corn to soybean to cellulosics and more. If you can go to my slide, right? So if you can go to the next slide, great. So Brian has asked us to share some thoughts on a few topics, and I was going to do that. The first one is around what are the renewable energy trends, along with what's driving these trends. And I see a couple of really material and overlapping trends. The first, and this surely doesn't come as news to anyone, is the focus on carbon. This can take different flavors depending on the perspective you're looking at it from, but in general, the new paradigm is really reducing carbon footprints. The second is really around focusing on strengthening supply chains. And this trend here is really towards establishing shorter and more resilient supply chains. In the old days, we would have talked about this as energy security, but today I think it is more than just a general bias against global trade. I think it's really more about resiliency in the face of disruption. The second topic around what's agriculture's role in meeting these needs, and here obviously you need agriculture to make renewable fuel, so that for sure is part of the solution. In addition, there's a lot around how agriculture is done, both crop and animal farming, and the practices used that have a big impact on carbon footprint. As it relates to the third question, role that the organizations I represent have in pursuing these trends, I have just a few slides to talk about a couple of concepts that I'm working on. So if you can go to the next slide. One of the companies I represent is called Next Chem, and it's part of a large EPC contractor that's very active in the energy transition space. Among other things, biofuels, but more than that. So if you go to the next slide. So one of the solutions we're working with is this idea of a regional scale sustainable aviation fuel renewable diesel solution. During the panel, I think we'll talk about the trends in kind of the renewable fuels and specifically the renewable diesel space. We think this is a really compelling solution where you bring the value that's in the market back to the feedstock by enabling solutions to make renewable diesel and sustainable aviation fuel at a regional scale with captive feedstock, be it distillers corn oil from a corn ethanol plant, be it animal fat from rendering operations, or even soybean oil, but regionalized solution. If you go to the next slide, another really interesting concept that's starting really to gain momentum is the idea of green fertilizer, and really the value proposition around green fertilizer in the local ag ecosystem. So what's the benefit of, green ammonia and green urea? So first, it reduces dependency on fossil resources. It shortens the fertilizer supply chain. It invests in the local economy. It has definitely benefits in terms of carbon intensity score that can be monetized, for example, in the ethanol market. It leverages the potential for local renewable power generation. The company I'm working with has a solution, a proprietary solution for small-scale ammonia and small-scale urea. So if you go to the next slide, and here I just pasted an announcement from the USDA that talks about substantial investments being available to support, regional fertilizer to give U.S. farmers more choices in the marketplace. So with that, I kind of wanted to turn it over to the other panelists and looking forward to the discussion.
All right, thank you, Michele. That's a lot of different types of things we're looking at. The next person I want to introduce is Steve Songa, who is the executive director of the commercial aviation. I get it wrong. Commercial Aviation Alternative Fuel Institute? Initiative. Okay, almost got it right. Should have written it down. Steve is a commercial aviation professional with broad strategic airline, aviation, OEM, and sustainable airline fuel experience since 1985. Throughout his career, Steve has been a strong industry advocate who has worked in the roles of developing pragmatic solutions to the challenges of aviation growth. So I will hand it over to Steve.
All right, thanks.
Appreciate it. And if y'all want to come up front, there's some Comfort Plus seats up here with extra leg room sticking out the front. So I provided 5 slides, but I'm actually not going to use those except as a summary and to give you my contact information. CAAFI is an initiative put together by the industry to foster the development and commercialization of renewable jet fuel for the aviation enterprise. And it follows directly on Michele's comments. We can make that renewable jet fuel from a lot of resources, things that nature hands us: fats, oils, and greases, sugars and starches, lignocellulose generally, and quite a few waste streams or circular economy byproducts, depending on how you want to look at it. Things like municipal solid waste makes good jet fuel, actually. Wet wastes like sanitary waste treatment residues, manure systems, food processing wastes. Actually going clear back and capturing carbon monoxide, carbon dioxide, hydrogen, waste products that come off of industrial processes. So it's really fairly fundamental chemistry. Any product that has hydrogen and carbon in it, again, nature hands us a lot of those things. Some of them are in very neat form for us to convert. Others a little bit more problematic. But we can simply use chemistry. We can use biochemical and thermochemical processes. Biochemical is what you all think of with respect to the production of alcohols. We're using microorganisms to convert sugars into alcohols. We can use microorganisms to convert into other intermediate forms of hydrocarbons. And then also the thermochemical processes, which is man-made kinds of processes using reactors at temperatures and pressures to deconstruct hydrocarbons to the form that we want them, and then sew them back together into jet fuel at the end of the day. So that's what we're doing broadly. We've been working at this for 15 years on a regimented basis. We've created all of the foundational stuff to allow this industry to take off. Just this past year, we've gotten very close collaboration with the federal government now. They announced the Sustainable Aviation Fuel Grand Challenge in September. You'll be hearing a lot more about that over the next few months. There are already several funding announcements that have come out of USDA and DOE that can help people get involved in the concept of the production of sustainable aviation fuel from these multiple sources. The challenges in front of us are being able to do what I described at a reasonable price point, right? And the airlines certainly would like to buy those renewable fuels at a petroleum equivalent price point, but in many cases they're currently higher. There are policy mechanisms in place that make the production of these fuels profitable for producers, and there are some bunch of sticky wickets out there that we're dealing with. Like Michele brought up the concept of working on renewable diesel. Well, any process that actually produces renewable diesel can also produce renewable jet fuel. You just have to fractionate it differently. The problem is policy doesn't create a level playing field. And so right now, there are producers in the US who are planning on 10 billion gallons of renewable diesel capacity in the US. And the reason they're not planning on a significant amount of SAF is because policy rewards renewable diesel production significantly, on the order of 60 cents a gallon or more. So that's why we're seeing all that. And there are efforts in place to try to level the playing field with respect to policy, utilizing these government programs, et cetera. And so with that, I will go to this summary, which I'll leave for you. And those are the key aspects. What's the size of the market? 26 billion gallons in the US, 100 billion gallons worldwide. We're an industry that's actually growing at 3 to 5% per year. These fuels deliver what we want, which is net greenhouse gas reduction. We know how to make them. technologies all the way from things that are producing fuel today to some very early stages. We're working collaboratively together with governments and others. There are actually 6 facilities online now producing this fuel. If you've flown through LAX in the last 6 years, you have a very modest amount of renewable molecules in the fuel tank. They're fully drop-in fuels. We don't have to modify airplanes, infrastructure, airports, etc. What we're working on is enabling affordability with sustainability, and SAF is in line with the concept of this conference, is an enabler for expanded production from agriculture, silviculture, aquaculture, and human activities, and we look forward to taking advantage of those resources to meet the needs of our industry, an industry that's sort of begging for the solutions in the production of this fuel. Our industry is all in, and if you want to talk more about that, I'm happy to do so. Thanks.
Thank you, Steve. Our next speaker is Andy Dvoracek. Andy is the Vice President of Business Development for AM Americas. He specializes in the origination and development of biogas projects. He has a wide range of experience in agricultural, industrial wastewater, methane avoidance-based renewable energy, coal mine methane, and biogas to pipeline quality gas conditioning. And he has a bachelor's degree in biology and environmental science from St. John's University and a Master of Public Administration and Environmental Policy and Management from Columbia University School for International. So, go ahead, Andy.
Thank you. First of all, I want to extend my appreciation to Ari for letting me speak today. Similar to what Steve does, we're in the business of biogas and alternative fuels. So my company, AMP Americas, we started in 2011, and we originally started working with a large dairy operation in Indiana, and our job was to move milk from their farm down to a processing facility. And we did that by purchasing, operating compressed natural gas trucks. And we put over 4 million miles on 40 trucks that we owned and operated. And then we built a compressed natural gas filling station network that was about 25 stations. This was before carbon was a hot topic in and around waste streams. And so the value we got from the gas we produced was largely attached to the an EPA program called the Renewable Fuel Standard Program. Since then, California has created its own program called the Low Carbon Fuel Standard. And essentially what it is it takes the federal program and it goes to the next level in the state of California, similar to the CAAFI standards for vehicles. And so we supply gas from our projects, biogas that we refine and produce a injectable gas that goes into the natural gas pipeline. There's an indistinguishable difference between our gas and natural gas in the pipeline, so we have to meet a specification. And then we sell that gas into fleets and vehicles in California. And in the process, we generate renewable energy credits, LCFS credits, as well as the thermal value of the gas in itself. So this is just a quick history of the company, how we evolved from the entity that was using the fuel to now the company that produces the fuel. We were the first company in the country to do this in 2011, in that we converted fuel from a dairy operation to biogas and then sold that gas into the market. And so going through the process of being the first to do it, we learned a lot and we lost a lot of fingers and toes in the process. But since then, the market has grown pretty substantially. The economies of scale in the particular space we work, which is mostly in the dairy space, requires large operations. So we work with very large dairies and we work with the largest of the large, and it's very hard to work with smaller projects. So there's a select number of those projects. We also are able to do similar activities in other waste streams like wastewater treatment, food waste digestion, as well as landfills. There's a difference between all of those based on the credit valuation and the pure economics. I won't get into the weeds on that. As a company, we build, own, and operate. So we're an investor in these projects. We've raised capital a couple different times through private equity. We've placed hundreds of millions of dollars in the space. We have active projects in the state of Minnesota, Indiana, Idaho, and we have projects in development in numerous states across the country. Like I said, we used to be the only ones in the space. There's probably about 10 serious companies in the space today, and it is a very competitive space. Just again, a couple more points on who we are. I apologize for the commercial company, but they pay my salary, so I have to say who we are and what we do. But at the end of the day, the goal of the company is to reduce emissions, create alternatives and transitions from fossil fuels to domestic fuels, and in the process, overall reduce emissions across the board. So I will stop there, leave a lot of opportunity for questions or comments. Appreciate it.
Thank you, Andy. Our next speaker, and final speaker, is also remote. Jesper Ascanius Kjersgaard Nielsen, if I got that name right. Apologize, Jesper. Is Vice President of Business Development at Nature Energy, where he works to develop Nature Energy's renewable natural gas presence in the Midwest. Jesper has a degree in mechanical engineering energy from the University of Southern Denmark. So go ahead, Jesper, and I will advance the slides when you give me direction.
Yeah, thank you. Can you hear me?
Yes.
Okay. I have to apologize for my voice. It's springtime here, so I get one of those spring colds. So please do the next slide. And the next slide, please. So Nature Energy in a glance. We are known as one of the world's largest producer of methane biogas. And today we operate 12 large-scale biogas plants, and we got 2 more coming within very few months. I was just visiting one of them this morning. We also produce biogas in France and Holland. In France, and we develop in France and Holland, and as well as North America, being both US and Canada. And in 21, we did 5.5 million tons of biomass, which correspond to approximately 225 million cubic meters of AD methane gas. And that is enough to drive 14,000 trucks, 50,000 kilometers, which is about 45,000 miles. We are a fully integrated renewable company and a truly develop, build, own, and operate company. Next slide, please. We are not super big when it comes to, let's say, human beings, but we use a lot of consultants in our way of approaching markets. So here you just see the numbers of our today. All our biogas we produce goes to grid, and we produce approximately 30% of the entire gas production in Denmark as we speak. Next slide, please. And our growth started almost the same as AMP back in 12. We came out of a company selling fossil natural gas, and we took over to start making renewable natural gas, and we call ourselves renewable-based. And I'm not going to walk through all these plants that we have in Denmark, but a milestone was, of course, as you see in the middle, when we purchased this Exegear, which means that we have our own engineering and EPC arm now. Next slide, please. So compared to others, we have the so-called nature energy model, and I like to call it the nature energy model in American context when we go into the US market, because we are not trying to put something down people's throat. We want to be a good neighbor and adapt to the reality that we have there. But basically, the short version is that we pick up manure and we bring back the needed nutrients to the specific farmers. And that gives the farmers a lot of opportunities to do right manure management, and, for example, not to pollute the groundwater, etc. And we also are capable of doing moving some of the fossils around. Hence we are picking up manure. Our model is suitable for both, and I say in brackets, smaller farmers, because they can actually have all the way down to 20 cows, and our model will still work, but we will of course also work with larger farmers to that extent. We have a mission that we like to, or at least we tell ourselves that we like to make renewable natural gas less costly by investing in technology and know-how, as well as, of course, process. Next slide, please. So in a bigger picture, biogas, as we all know, is a circular economic when it's best. And here at the right, you can basically see what we are doing. We're picking up manure and other organics, and we like to co-digest. And then we bring back nutrition back to the farms again. And my message here today is that where we will like to increase and are increasing our way of making renewable natural gas less costly is the top line there, where you can see we have 40% CO2 that we will do all kinds of stuff in order to bring even more methane gas. Now, power to X is one, of course, but we also have something else, which I'll show a little bit later. And we all also know that gas in this big picture of, let's say, solar and wind, natural gas, or renewable natural gas is a component in our society that we need in order to fuel our, say, more heavy industries. So next slide, please. And here's a picture of one of our lab girls. See, next slide, please. So when it comes to that, we believe in efficient carbon utilization. And here's just a brief, where we have the feedstock with 100%. We take that through the AD reactor, and about 40% goes further to fertilizer. With a separation, we can take phosphorus away, we get some fiber, we can use that for all kinds of stuff, and then we get a good liquid fertilizer for the farmers. But the interesting part is, of course, the 60%, as you see, the arrow goes up, that we can produce more biomethane and of course have less CO2. Next slide, please. So here basically comes what I like to say today, that what we're working on is that you see at the far right, far right, is that we are looking very much into doing a methylation, but not as a traditional, when everybody thinks about that, as a power to X, or we have a lot of wind and electrifies, but doing in a biologic way. And we are putting a lot of efforts and resources into that. And we are also having industrial testing facilities going on as we speak. So I hope that this will work out fine, which we strongly believe in, and then we will have even more production and falling up to our mission to have less costly RNG. Next slide, please. Yeah, that was my 5 minutes. I have a lot more to tell, but I was only allowed to have 5 minutes. Maybe just one last remark here. Our model has the farmer and crop growers very much in center in order to give the right fertilizer back to these, and please feel free to ask any questions. Thank you.
All right, thank you. So now we're going to have a chance for question and answers. I'm gonna start, I guess, as the moderator to ask a question of all four of our presenters. And the question kind of generally that I have across all the different kind of markets and technologies and products that will be discussed here is that in order to really bring these things to scale and kind of get to the kind of decarbonization goals, which is what my organization, Great Plains Institute, is really all about, is there additional innovation that has to happen, or is the product or service already poised to move ahead? Do we need new technologies? Do we need new innovation, or are things ready to go? And I want to hear from all four presenters, so I'll start with our online presenters. And Michele, if you can kind of answer the question.
Great. Yeah, you hear me, right?
Yes.
Okay, great. Well, I mean, I think definitely there is room for innovation. You know, we do expect new technologies. Jesper talked about methanation, biological methanation. That's definitely new emerging technology. E-fuels, there's a lot given the interest you know, at work on innovation and new technologies. The good news is that there are plenty of technologies that can move the needle right now. Renewable diesel and sustainable aviation fuel from oils and fats. That's pretty much demonstrated technology. Green fertilizers. Those are proven technologies. There's going to be kind of a support needed in the scale up. Maybe the real innovation that's needed is policy stability, and I think we're getting there. I really do. So I'm a glass half full guy when it comes to all of this.
Okay. And Jesper, can you talked a lot about renewable natural gas. Is the technology ready, or do we need new innovation in order to bring it to scale?
Yes, if we succeed with our industrial scale test, we will, and this is also this nature energy model, we will implement this at all our plants in Denmark. I mean, the plant you see behind me here is one called Korsro, where we pick up the CO2 and we make it to a food grade product, and it goes in the beers in Denmark. So when you have a beer here, you might want to think about where the bubble comes from. But that way is it's a bit expensive. So we're waiting for the others, and then we'll implement that on all. And I believe as long as we are getting along with our projects in Minnesota and Wisconsin, as we speak, that we will be able to implement that in when we start up in what is that 23. We will make a standard industrial scale plants, and we need to make that standard because the amount of plants that we like to build calls for standardization. So all our plants will have room for this miniaturization, either by power, if that's available, but I believe personally more in the biologic way, because it simply do not call for power, and it's just there's so many pluses. I cannot say in details, of course.
Okay, thank you. And Steve, you did actually address this to some extent in your remarks already, but if you could just kind of follow through and you talk about kind of some more policy barriers to sustainable aviation.
Yeah, for sure. So the approach that we've taken, because we really care if an airplane is in the air and the fuel doesn't work and the engine shut off, right? So in our industry, what we have done is created this framework where each type of conversion technology actually gets qualified by the industry, very careful evaluation, test work, etc. So we've done 7 of those so far. Fischer tropes, these are not going to mean much to you, perhaps. That's using lignocellulose. HEPA using fats, oils, and greases. A couple processes using the conversion of sugars. Alcohol to jet pathway, catalytic hydrothermolysis, etc. So we've got 7 done. There are another 6 that are in process right now, and at least another 15 beyond that. And I'm very interested in seeing those additional processes come to play, because what all of them are focused on is reduce cost, either in the final product, typically driven by a reduction in the feedstock cost that you're able to use, or a reduction in the capital expense of the facility that you have to build to produce these fuels. So yes, absolutely, the aviation industry is looking very forward to the continued development and bringing online some very advanced technologies, or even some tweaks to technologies that will just continue to ratchet down the cost and make these things truly ubiquitous from a very broad range of resources. And a key feature in that resources issue is if we can utilize these 24/7 kinds of waste streams, which typically have very low cost, in some cases they actually have negative cost, right? If you look at the MSW market in New England and West Coast, the company that hauls your trash away actually pays a tipping fee to the next person in line who takes that trash from them. So a converter of MSW gets a negative cost feedstock. So there are cases that are being worked right now where those companies actually don't need a government subsidy to make profitable fuel at today's petroleum jet fuel pricing. And that's not the case with every feedstock and every conversion technology. So there are pockets of light out there for that kind of stuff. But think about the order of magnitude in front of us. I said it's 100 billion gallon per year market. And this past year, we, as an industry, produced 8 million. 8 million out of 100 billion, right? So we've got a lot of runway in front of us.
Okay, and Andy, what's up for the biogas? Is there new innovation needed to bring it to scale?
Yeah, there's definitely new innovation needed. As I said earlier, we really work with the large of the large because the economies of scale are imperative. To process 500 cubic feet of gas into a refined product compared to 1,000 is not that big, right? And so the economies of scale are imperative and important, particularly on the gas processing side. On the production of the gas, it's really linear. Digestion is predominantly steel and concrete and volumetric. So there's evolutions coming there for sure. A lot of those evolutions have come from across the pond in Europe, because there's enormous incentives in Europe around energy. And what's happening in Ukraine right now is an energy problem. And so Europe doesn't have a lot of resources, so they get their resources from the likes of Russia through Ukraine, and that's why there's a conflict there. And so evolution of technologies that have to date been driven mostly from Europe coming across to the United States. But the United States, through its market development, are really taking the step to the next level. We've seen evolution in engine technology. For the longest time, we didn't have the right horsepower engine in compressed natural gas, and long-haul truckers didn't have what they needed as far as horsepower. Just recently, Cummins just announced that they're coming out with a new engine that's going to be a market-changing technology, and it will increase the demand drastically. At higher prices of diesel, the economics of CNG are drastically better today than they were when diesel was cheaper. So we see in a lot of technologies, when fossil becomes more expensive, alternatives become more viable. And so we're starting to see those kind of evolutions and changes. Then the other evolution, which I think is imperative, is policy. Right now, we supply all our fuel into the California market, and that market is becoming saturated with our product. Renewable gas now supplies the majority of all compressed natural gas utilized in the state of California. We supply as a company over 50% of the hydrogen for the entire state of California. And so we need new markets, new opportunities. There are initiatives in states like Minnesota and Colorado, New York, New Mexico, and other states across the union that are looking at alternatives. The utilities are also getting into the game. The reason they're getting into it is the only way they can reduce emissions is finding alternatives for renewable in their gas streams. Because people are going to continue to use gas because it's still the cheapest, easiest product to use for heating. And so the only way you can reduce emissions as a utility is to change the carbon footprint of your gas. Small amount of biogas changes a drastic amount of fuel that they have in their network. So we need definite evolutions, and everything's driven by economics. And so that's where everything's moving.
Okay. So let's see if there's any questions from the audience. I have more questions, but let's go to the audience. So somebody have a microphone? Are we going around? Okay. I guess, should we just logistically here, move that around? Okay, there we go.
Well, thanks, that's all. Super panel, thank you very much. Question regarding the aviation fuel and international standards. I'm just wondering if Steve could comment on what the international standard is, whether or not it's a moving goalpost or could producers rely on that? What the airlines themselves actually use that as a benchmark in their spec of product?
Yeah, so that's the foundational nature that I was referring to earlier. There's two predominant jet fuel specifications. One that the Western world uses almost exclusively. It's an ASTM defined specification, B1655. There's also one in the UK. There's also one in the former Soviet Union states that's used, the GOS spec. Fundamentally, those specs are relatively firm. They have been for years, and we continue to use those. New aircraft and engines continue to be developed to utilize those fuels. And this is something that folks don't realize, but jet fuel is a really capable fuel system for aircraft. It has the safety aspects, the energy density, the energy per unit volume and mass. It's a great fuel. And actually thinking freely about, could we do something else? We have a hard time coming up with anything that actually beats jet fuel. And that's why we've pursued this path of creating biofuels that still meet the jet fuel spec. So from a specification perspective, pretty firm. We're continuing to work in that, and we're continuing to find all of these ways to produce renewable fuel that still meets the spec, and in different ways. There's some other, I assume that's the aspect that you're asking about, technical specification of the fuel itself. Yeah, that's exactly, that's where I was going and assumed that you may have thought that. So by international agreement, there's an understanding of greenhouse gases associated with the standard use of jet fuel, 89 grams CO2 equivalent per megajoule. That varies actually pretty significantly depending on where the crude comes from and the refinery that produces it. But on average, that's the level that's being utilized to measure improvements from that baseline. The airlines, especially in the US, have all committed that for the renewable fuels that they intend to use, that they are only going to start out with fuels that achieve a 50% reduction from that level, because they're using the RSP framework for that, for the valuation of those fuels. And RSP is probably very soon going to move to a 60% reduction baseline. So that's the kind of level that we're talking about. Additionally, when we take advantage of policy mechanisms, those policy mechanisms typically have a reduction level required in them in order to take advantage of the policy. US RFS, California LCFS. The LCFS is beautiful because it actually rewards every unit of reduction that you achieve. So each individual producer can get a score for their fuel, and that reduction from the baseline is actually creates value in the marketplace. So we're interested in more kinds of policy mechanisms that actually get to that level. And then finally, it's not just greenhouse gases. These fuels are actually superior in a few other ways. Plus, they often are providing other environmental services that today there are no policy mechanisms that reward those things beyond greenhouse gases. But in terms of water quality and some of the stuff that follows the fuel molecules all the way back to their source, there's some benefits going all the way back. We're working with RE and University of Minnesota on a crop called pennycress. It's a winter cover crop that can be used in the corn soil rotation. It provides all the value of a cover crop, plus provides the farmer revenue associated with that. It does some things with respect to good things, with respect to nutrient leaching, soil erosion, water erosion, pollinator habitat, perhaps some benefits with respect to nematodes and some other things. So there's other environmental services coming along with some of the feedstocks that we're using. But yes, technical specification, well-defined, greenhouse gas specification, fairly well-defined. We continue to make progress with respect to delivering fuels significantly under that spec, those specs, including some really neat work going on right now, including the production of carbon negative jet fuel, which is a real testament to the creativity that some of these producers are bringing to the table. All right.
So another question from the audience.
Thank you. This question is for Steve, kind of following along the same lines of kind of policy for sustainable aviation fuels. I know enough about the low carbon fuel standard in California to really confuse myself about it. And I know that there are pathways that have been approved for like tallow or fats and oils to be converted to sustainable aviation fuels, but to your knowledge, are there other pathways that have been approved, like for, you know, ethanol to jet fuel or sugars or starches? Yeah, that's my question. What's up with the pathways?
Yeah, under the LCFS, I don't think that there are finalized pathways for those others because they typically require an applicant, right? And because we don't have anybody producing fuels quite yet, there's one that's really close that would go into the California market. Then we'll see that. And so one of those first ones will be biocrude produced by Fulcrum in Nevada from municipal solid waste. That biocrude gets delivered to a BP refinery for finishing into jet fuel, which gets delivered into the California and Oregon markets. Oregon also has an LCFS system in place. So I think you likely will see those soon. I might be remiss in not knowing that they're actually already published. I just haven't taken a look at them. But yeah, that's the process, the way that it works. And California has been very responsive, actually, to petitions. In fact, the Paramount refinery has multiple approvals, depending on where their feedstock comes from and the supply chain elements that they're using. So California has been great at acknowledging and rewarding, as it were, those carbon reductions, as opposed to my dear friends at EPA, which have a tough time advancing any additional approvals. It's tough.
Do any of the other presenters want to make a comment on that question? Just offer. Okay. Well, any other questions from the audience? Go ahead. Yeah.
Thanks. Now moving to the biogas side of things. I'm just wondering in terms of some of the things we just heard from Steve, there seems to be this attention to water quality issues, other ecosystem support factors. I'm wondering if you could address that with respect to the biogas and whether or not there are any standards or co-benefits, if you will, in the way in which the organics are collected and how that relates to the generators of those items.
Sure, I can talk a little bit to that point. There is a growing interest in nutrient recovery, particularly nitrogen and phosphorus, depending upon where you are in the country. You've got surface water problems, like you do in the north, or you've got aquifer nitrogen problems, which you have in the southeast. So nutrients is a big issue. What we've seen precipitously in the last handful of years is the size of farms, and in this case, the size of certain animal operations have gotten bigger because the economies of scale are imperative. So what we're doing is we're creating nutrient lines in the process. We're creating super efficiencies in the production of milk and protein, which is why the economies of scale matter. The difference between a 2,000 head dairy and a 6,000 head dairy is drastically different on the economies. And so you're seeing the small guys go out, and the big guys come in. We still have 50,000 dairy operations in the country, and there's probably only 200 of those that are 5,000. But we're moving in that direction. And so nutrients are becoming increasingly important. We've got major issues in Wisconsin, in particular around surface water issues. Wisconsin is the second largest dairy state in the country, and they've got surface water problems because of manure. In the southeast, you've got nutrient problems because of the aquifers, nitrogen in particular. The technologies are here; they work. Our project in Indiana built a massive fertilizer plant, which took a cake product, which was created on the back end of digestion, and created a micro fertilizer product, which they sold in the market. the Farmerman project in Benson, which has recently been shut down, created a micro fertilizer byproduct that they then sold. The biggest problem with fertilizer is the cost of fuel dictates the market. And so the technology is there to create these alternatives, but the cost of getting it to market and getting it to end users causes problems in competition with traditional fertilizer types. The advantage of digestion in particular is that's the first step in needing to do nutrient recovery. It's step 0. So the more projects that we can get that start with digestion, we'll see then in the future the evolution of technology, more importantly, the evolution of markets, which will create the economic incentive to look at these alternatives. Today, there are states that are starting to track nutrients and track environmental issues in and around agriculture. But they haven't had any standards yet as far as policy that are starting to push toward regulation. We see that in the future, which is part of the reason we're trying to get the next generation of farmers motivated in and around these technologies. We talked to upstairs, there was someone talking about succession. It's a major issue in the agricultural space. You often have a couple offspring from a family, and the requirement to economically sustain a family in agriculture is drastic. So you have one family with 3 kids, and those 3 kids all of a sudden become the next generation at farm. You've got to triple or quadruple the size of that farm to make sure everybody around are fed. You also need that next generation to be capable and willing and interested and excited about agriculture. Today's market is a little bit tough, but getting the next generation excited about renewables and alternatives is the avenue to try to make pushes happen. So I kind of got off track there a little bit, but got on my soapbox. But I think there's a lot of opportunity around standards as we go forward, but everything's dictated by markets. Right now, the economies need to work to make this happen.
Okay, our online presenters, anything on this question of LCFS and how it fits with biogas? Biodiesel, I guess? Just going to offer, make sure that you have an opportunity to chime in. Any other questions from the audience? Go ahead.
Since I'm holding the mic, this is for renewable diesel. Given the escalated price of vegetable oils and animal fats, is there a threshold where renewable diesel becomes not competitive in the marketplace, even with the subsidy?
So it's an interesting question, and it's a little timely. We produce a biogas, and we can convert that biogas to renewable ammonia. We can convert it into a sustainable aviation fuel. We can convert it into hydrogen. We can convert it into a variety of different products. Biodiesel is one of them. One of the things is we're also we're a victim of our own success. So one of the things that's happening today is the success of the biodiesel market is creating some problems for the LCFS market. In particular, the supply and demand dynamics. So we've recently seen in the last couple months the value of LCFS credits come down pretty drastically. And the reason it's come down is there's been an influx of biodiesel in the market, which is producing a larger amount of credits than the market can produce. So we need more markets to create more demand, which then motivates more people to do more projects. I think we've seen an interesting dynamic around biodiesel in particular because of motivations around carbon and different feedstock pricing. But you also see the increase in fuel or crude at the same time, which has an influence on the price of diesel at the end of the day. So there's a lot of dynamics moving back and forth within all those markets. And I don't know if I directly answered your question, but it was time that we're seeing pretty drastic change in how the market works today. The reason that's important is right now the markets that we sell, at least our products into, are illiquid, and because they're illiquid, we're unable to get a long-term sustained financing in the form of debt. All of our projects are 100%, so it's very high-risk capital, requires a different level of diligence than if you were able to bring in 80% debt on the project. Because of that, these projects are harder to build. And we're starting to see more bonds coming to the market. We're starting to see some banks wanting to underwrite this, but I can tell you this the last couple months because of the craziness of the market. I think a lot of banks are trying to get that. And there are good projects out there. They all make sense on paper. It's a matter of you can actually get them across the line. I keep harping on the economics. I hate hit on that point, but that's how we really got it.
Michele or Jesper, yeah?
Yeah, I have a few comments. First off, just to Steve's earlier point, I did quickly check, and Fulcrum does have an approved pathway in the LCFS at the CI of 15. I just quickly checked while we were talking. But so Fulcrum, the fish trope diesel project in Nevada does have an approved pathway at the CI of 15. To the question being posed right now, I don't see the feedstock pricing becoming a limitation to renewable diesel demand, because the way the market is structured, the market needs renewable diesel, and the demand is quite inelastic at this point. If you look at how LCFS, RFS, and RED in Europe work. So that's what's happening actually. Feedstock prices are continuing to go up, and the demand side is able to absorb those increased costs. And I don't see that changing. Specifically in California, to meet the CI, the CI reductions with the shrinking gasoline pool, I think the market will accommodate renewable diesel.
Any other questions from the audience? A few minutes left.
I'll just add on that last question. There's another approach to that too, right? We see this all the time. There's a lot of hand wringing around the world with respect to moving into renewables, and people comment, well, there's not enough of this and there's not enough of that, and that's no good for XYZ reasons, etc. Well, from an aviation perspective, we have a little bit different philosophy, because we're looking at this fuel as the long run solution. Really, we're not going to see hydrogen powered aircraft for at least 3 decades, irrespective of some of the noise that you hear, and work that's being done on real small vehicles. So we're relying on sustainable aviation fuel. And so the approach that we're working with the government right now is, let's not do hand wringing. Let's actually get to work on things like additional cover crops that produce oil seeds, just as one example. But there's a revolution that's taking place right now with respect to bringing back additional sources of lipids across the world, not just in the U.S. So we can see significant expansion. Carinata is now a commercial crop in Argentina and Uruguay. It's going to come back into the southeast U.S. Pennycrest works across the entire Midwest space. There's work being done on tongue oil in the Gulf of Mexico crescent. And you get into the tropics, and it really opens up a whole category, right? The Indians in the continent of India have something like 40 some different species of plant that produce an oil seed of one type or another. And like 6 or 7 of those look very promising for them. So there's a lot of work going on in the world right now responding to this issue of, no, we can't get enough from animal processing and soy oil, but there's a whole group of other options out there that we can bring on board sustainably without indirect land use change, and we're working to foster this. In addition to everything else, the reason that we got to focus on oils goes back to the statement I made at the beginning. Nature hands us a triglyceride. Those molecules look almost identical to what we actually want to burn. You cut off the triacylglyceride backbone, and you're left with these chains. They look just like fuel with a few tweaks, right? So if I hydroprocess them, I wind up with fuel molecules. So very low processing costs associated with doing that. So I continue to focus on bringing down the cost of feedstocks expanding, and I very significantly have the opportunity to increase supply. And then
looking to the guys who are working in methane and renewable hydrogen. I'm very encouraged because for every gallon of jet fuel that we make, we actually have to have hydrogen to do that final tweaking of those molecules to get them into the right form. So a lot of the stuff that's happening across the entire energy space is very synergistic, and to me bodes well for the future that we need to always strive.
All right, thank you. We've reached our allotted time, so we managed to fill it up. Probably have some more questions, but when everyone, let's give a round of applause to our speakers, our panelists. And I'm sure that at least the ones here will be happy to stand and answer some additional questions. And that's the time. So thanks, everyone.